Hello, everyone. Hi, Inu. How are you? Very happy to have you here today. Great projects working in the data availability atmosphere. We'll know that maybe doing different things slightly, and hopefully we will give that nuance today to the audience. So as we get started, perhaps we can go with like quick intro about yourself and generally like what data availability means in the context of your project. So we can understand a little bit how you approach this topic from each angle. Prabal?
Hey, I'm Prabal. I'm one of the co-founders of Avail. What data availability means to me and Avail in general is essentially the source of truth for ordering and consensus behind rollups. So if people are unaware, like rollups need to publish data on which they have their execution proofs of, hopefully, and that becomes the source of truth behind whatever guarantees that they provide to their users. So data availability for us is the main basis on which the rollups and the verifiable compute layers work.
Hello. Jacob, CSO at Celestia Labs. So on the DA side, like the way we think about it is like obviously, one of the projects that kind of made it alongside the ETH-centric, rollup-centric roadmap on Ethereum, made it kind of like come into the common discussion is that basically you think about what the core bottleneck is for scaling up this whole blockchain ecosystem in terms of what applications need in a world of many chains, et cetera. It's obviously going to be what makes what the bottleneck is for rollups and that's ultimately DA. And so we're focused, for example, on scaling up the DA throughput to gigabytes per second. We just put out a roadmap to do that. And ultimately, we think that's going to basically start to create the convergence between basically where crypto applications are today, which is like a very small number of thousands of TPS, to a world where it's compute is and throughput is completely abundant, and you can deploy an application the way you do in traditional Web 2.
Hi, I'm Muriel Medard. I'm co-founder of Optimum from MIT to pursue this full time. I'm going to change your question a little bit from availability to access. So what we're looking is data access. And our idea is, if you look at your computer, you're accessing data, you're reading and writing, and you have your own dedicated RAM, you have your own dedicated bus. You don't worry about it. Right, you don't have to go and check all the time. There are processes in the background, of course, that check that the data is what it says it is. But what we're doing is, in effect, making the entire Web3 just look to you like it's on your own computer, so that you can abstract that. And I think it's that data access and being really able to program like we learned to program, right? Just on your computer, not have to worry about it. That's what we're doing. And in order to do that cheaply, quickly, in an economical way, we have to use coding. So that's what we bring to the table.
Got it. Smart approach.
Hello everyone, my name is Kimura, and I'm a co-founder of Sunrise, and Sunrise is a specialized DA layer for proof of liquidity. In our view, the layer is conventionally a layer to secure the blockchain network, not to allow malicious behaving operators to withhold the data, hiding the transaction data to act double spending or something like that. But in the perspective of modular paradigm, it is an important part to scale up the entire ecosystem by enabling, for example, data availability sampling or any other technologies like modifying the Markov trees and so on. It is, I think, the DA layer is the most important layer among all 4 layers. Typically, we can say execution layer, consensus layer, settlement layer, DA layer part. In our view, DA layer is the most important layer among the modular ecosystem.
Thank you for being here. This is Marouen, and I'm building Crestal. I can tell you about it later. So we'll start actually with a couple of questions, and then probably for these questions, I will ask some of you to answer them. But if you do feel that you have something to add, please jump in. You're just not allowed to say, I agree. because then it's not, we're not adding. So let's talk a little bit about the verifiability and security of DA, data availability, and perhaps actually we're looking at Avail and Celestia. The moment we asked projects to move their data, let's say from Ethereum and put it on a DA layer, then the verifiability and security became a major topic. And so there are different approaches today taken of how we ensure that indeed it's secure, it's verifiable, different consensus mechanisms. So maybe you can share a little bit about what's happening, like what are the methods that are, let's say, common methods, and what are the difference between them? A bit of pros and cons to that would educate the audience.
Sorry, pros and cons of what exactly?
Perhaps like different algorithms or methodologies of verifying the data.
So essentially, when it comes to user level verifiability of data availability, the main thing that we want to ensure is end user verifiability by themselves, not having to rely on just crypto economic guarantees, but be able to verify through cryptographic means. And that is the reason, like for example, Celestia and Avail both has data availability sampling. What data availability sampling provides is that you can randomly pick and choose only small parts of the entire data, and then be able to have very high guarantees that the entirety of the data is actually available. Now that is very important, because when we keep talking about data availability guarantees and such and so on, sometimes it's easy enough to think that, okay, yes, if I can download my data, then I know that it's available. But that is very wasteful. I mean, that doesn't change any of the status quo. Like today, you can use any chain, almost any chain, irrespective of how they are built, what are their novelties and so on, as a DA layer if you have to download the entire data. They can differ in throughput, differ in bandwidth, and so on and so forth, in cost and such. But essentially, it can be done the same. So there is no novelty in making it without a data availability sampling in place, because it's so wasteful. Now, when we go into data availability sampling, there are different means in which you can give those guarantees. One of the ones that we use is what we call KZG commitments. How KZG commitments work is that there's a polynomial commitment over the data that you have sent. So it's a cryptographic guarantee that the commitment is binding to the data that you had submitted. So hence it's very hard to falsify that record. Once you publish it and it's recorded inside the ledger, it's very hard to falsify that I didn't publish it and so on. And you have to then sample it against that commitment. Celestia he can say a lot more, but I'm just speaking on his behalf right now. But they take a more optimistic approach. What the approach that they take is they commit, but in a hash-based scheme that has again different trade-offs, right? So there is no golden, there's no silver bullet in this space. Hash-based algorithms are faster, and they provide the guarantees immediately almost, right? Now, on the other hand, KZGs are costlier. Now, these are only on paper, but when in practice, because of the scale in which we are talking, the differences are so minute that we think it's a trade-off worth having. They, of course, might think differently, right? And these are the different trade-offs when it comes to end-user verifiability. Sorry for the long-winded answer, but in the end, there is also Validium constructions where the users of the rollup listen to only the settlement layer and not directly to the DA layer. There, the guarantees come through the bridge, and the bridge can only verify consensus. So although we would love for every one of the rollup users to be data availability sampling light clients and verify DA themselves, in reality, we sometimes see constructions where they only rely on the bridge, where it becomes important for the crypto economic guarantee of the chain to have the say, because that's their source of truth.
Yeah, I think the other, to summarize kind of how I think what it ultimately brings to crypto is, building on what you're saying at the very beginning, is that until these constructions, until DAS, basically all crypto, all blockchains, basically all applications on blockchains are secured by basically a committee of chains, and then and the full node operators of those chains, right? And that just does not scale to the planet. It does not scale to billions of people understanding what the trust assumptions of what they're interacting with. And the whole point, that's fine in Web 2. You have the whole point of, in Web 2, it's you don't even think about trust. You're just okay, well, it's a cool service, I use it, whatever. In crypto, though, the whole point of this system is that it has some level of trust, either censorship resistance or unstoppability or trust minimization guarantees. And so if you're going to build that, and if you want to really scale it up to like, really do the kinds of things that we hope, crypto can do in the future, then it has to have this end user verifiability property, or like that. The fact that we if we're going to have things that everyone on the planet's using, that's the only level of like you basically have to have something where end users can verify the correctness of what's being executed. And so I think that's like really the way to think about it. An emergent way is like more of like how the industry kind of build all these walled garden, like single L1, and there's obviously Solana, for example, people like Monad, they're taking that to the absolute limit in terms of like what you can do on a single monolithic design. But this philosophy is more about basically what does it look like where if we take a really long view and instead we want to make it so that every person everywhere can verify what the hell is going on. So or that is correct rather. And so I think that's really like the way to actually think about why this verifiability property like really matters.
Can I have a simple question?
go ahead.
How much the cost to generate KZZ commitment?
Yeah, it's extremely cheap. It takes order of milliseconds to generate one commitment, at least for the sizes that we are running in production right now. Even with 128 MB blocks and beyond, it takes in the order of tens of milliseconds. So it's not really a bottleneck there. It takes at least one order of magnitude cheaper to do it in hash-based schemes. So let's not kid about it. But given the scale, like when we talk about 1 GB blocks, then maybe the delta is very high. I don't know. We have to benchmark it.
Makes sense.
I know you said don't say I agree, so I'm going to say I'm almost agree. I would just like to
I'll allow it.
generalize a little bit, because I think also when we're talking about sampling, particularly code-based sampling, say I think there's a much wider family of codes one can use, and in particular, it's perfectly reasonable to start with something like two-dimensional Reed-Solomon codes, but you can think of codes which are infinite in effect in their construction, and then you have an even richer set of challenges, because that's really the challenge question that the sampling does, because you have to say you can't crib the answer. There are other approaches also, like you can check it homomorphically, not with full homomorphic encryption, which will make your zero knowledge proof look easy, but just code homomorphism. So I think there's also just a very rich set of possibilities out there which haven't been implemented, but we know exist, and sort of can generalize beyond what's out there. So I think the entire design space hasn't been explored yet.
I mean,
Yeah.
agreed. But just to correct, like we use KZG, which is already homomorphic,
Yeah.
and it's not fully 2D erasure coding.
Yeah, I
like
meant homomorphic for the code
Yes.
homomorphic. Yes.
Yeah.
So, but you can do homomorphism without doing the ZK. But
It's not ZK.
oh no, I'm saying, but I'm not saying, when I talk about homomorphic, I mean not full homomorphic. Just
It's
code
not fully homomorphic.
Yeah, no, I understand. But
I'm just
saying
saying,
there
like,
are
yeah,
there are other
like
approaches,
everyone, we are pushing the space, and
Yeah.
yes, there is a huge design space out there that comes with its own trade-offs, right? So,
That's right.
like for
Yeah.
example, a single 1D erasure coding is of course more faster than a 2D erasure coding, but 2D erasure coding gives you much higher guarantees in terms of when you start censoring light clients on the peer-to-peer network. For example, I can go on for it.
Yeah. You guys following this? Yes. All right. Let's talk about something more about the economic model of this industry, right? So we are seeing actually increase in adoption in DAs, and we're seeing cost of blobs actually kind of normalizing. You mentioned, for example, the trade-offs in terms of costs are almost negligible, at least at the current scale. Maybe it will matter at in the future where there's thousands and millions of projects. For now, it seems like okay, it's blob cost, right? It's this access to the data cost. How do you see maybe more innovative ways from a business model for data availability players and the ecosystem around it to create new monetization or new incentivization that bring additional revenue to the ecosystem, rather than, of course, real estate revenue?
Well, I think the first thing to understand is that in this architecture, like in taking off, one of the really good things about it is that it gives people who are building applications a lot more control over how value flows through the system. And so what I call it is actually, there was this very in vogue article a couple years ago about the fat application thesis. It was like a rebuttal to like the rise of L1s and the fat protocol thesis. And the idea was that applications capture all the value, therefore that's where all the value accrue, etc. However, the problem is those applications also need to get access to users. They also need to get security. And so the way we think about Celestia is that it's not a fat application thesis. We actually think that's a subset of the story. The bigger opportunity is to create the lazy application thesis. And what that means is that you get to capture all that execution revenue, all that value, et cetera, but you also get instant access to all the users everywhere across crypto. And so that's kind of like one thing that we're working on. And Avail is actually taking a very similar.
Tap on it a couple times. No, then it's not working.
Yeah, I was saying Avail is taking a very similar approach with their unification like angle, right? Like the idea that all these chains, like when you create a new blockchain and you build an app on it, you should just get access to all the users, all the liquidity everywhere. Like that's just going to be a given in the future. And the only reason it's not a given today, and the reason why people think revenue is like short-term revenue of blockchains is very important as an infrastructure level, is that Ethereum is very hard to do this. So if you build an L2 in Ethereum, you can get all the distribution of Ethereum, right? But you can't get quick access to Arbitrum. You can't get quick access to, but like I'm saying, if you build an OP chain, for example, you can't get quick access to Arbitrum. You can't get quick access to the things going on zk sync, whatever. And so what we want to do, and I think Avail shares this a very similar view, is the ability to give people really high security guarantees out of the box when they deploy an application on our own chain and their own block space, but also get access to all the users and all the liquidity elsewhere. And the value of that is significantly, together especially, is significantly greater than just the short-term revenue you get, say, from DA. And we're not even thinking short-term about revenue. We think, like the way Solana, it took 4 years for Solana to have revenue, despite even having a decent ecosystem a year after they were live. We think it's going to take, because of what is going to be enabled by high throughput is so emergent and so new, we think it's going to take years before people actually understand how much value there is in offering that set of combined like lazy services. And so we think it's going to be like there's going to be totally emergent, weird, new products that get built that need mind-blowing amounts of DA, like amounts that like right now we don't even, like gigabit per second like level DA. And it's gonna that's where we'll really see totally emergent new stuff people use. And it's only going to happen if you're like basically offering DA at a really low cost. You're not trying to provide. You're not trying to extract at that like economic level.
But Kimura-san, you have an interesting model with your dual token as well. So maybe you can talk about
Sunrise integrates Prabal liquidity. In our view, it is too difficult to raise enough protocol revenue only with serving the blob spaces to address the data availability, because the technology is well commoditized already, even though we have many challenges to differentiate from each other. And so the reason why users use alternative DA layer instead of using Ethereum layer 1 is just is cheap. It is not the functionalities, it is just a chip. So it is inevitable to go to the race to the bottom. So in our view, we need to have another source of protocol revenue. And by integrating Prabal liquidity, it is similar to blockchain. We can raise protocol revenue from ensure the liquidity pool on Sunrise, and we also can capture MEVs in our liquidity pool. Furthermore, by capturing cross-chain MEVs with like a method like base rollups, we think that there are many opportunities to capture the value as a data availability layer, not only from the blob spaces.
If I could add something to the economic discussion, there's also the cost of the nodes, right? For the node operators, and I think obviously DA is allowing much cheaper checking. Of course that's as you said, that's why it's so attractive. But there's also for node operators, there's just the cost of maintaining the nodes. And what we're doing is we're creating a node client, which is called Flex Node. And because of the coding that we do, we're able to allow people to provide very few resources so that the barrier to entry is much lower. Right? So you go, okay, look, you can't have a full node. Got it. Can you have a quarter of a node? How much what can you give me and make that useful? So I think that, as you said, also not to go to the race to the bottom, but just making it much more affordable and, opening it up to a much larger set of potential node operators is another aspect of the economic picture.
Gotcha. Looking at the space now, there is of course multiple data availability solutions and data access solutions as well that hopefully will bloom as a category as well. Which means now projects will have to use some of them, and I think so far we've seen announcements was like, okay, this chain is using this DA or this chain is using DA. But recently we've started seeing also some announcements that are a bit similar to the old multi-cloud narrative, which is I'm going to use a multi-DA strategy, right, or use aggregated DA strategy. There is, I think, Manta Particle Network, they're doing this. I wanted to get your view on, but is this actually where the data services category will go towards, which is today people seek resiliency, and because of the cost of management is cheaper than they can afford to duplicate for resiliency? Like a general view on this will be very interesting from your side.
Technically, I think if the DA is itself not resilient, then they should not be using it. Multi-DA approach makes sense in terms of partnerships, of course, but also in terms of having like multiple redundancies available. Even today, some stacks already use Ethereum as the backup. So they use something like Celestia or Avail, and then as a backup, they use Ethereum. The question comes like, it's about allegiance, right? So, I mean, when I say source of truth, I come from there, is that what is your source of truth? In the code, there will be at some point will be made a choice between what the execution follows, which DA layer the execution follows. If one is not available, then go to two, then one is your source of truth. Because if the two DA layers do not agree, what is your fork choice rule is actually the one that to consider is your allegiance in some sense. So multi-DA approach makes sense, but at the same time, there is always a primary and a secondary or a series of secondaries. So it's important what is that primary, because when primaries and secondaries will not agree is when it shows up about what is the true DA that you follow.
Yeah, I personally just think if people want to do that. So first of all, when we launched Celestia, one of the first things we did not long after it was when we were doing an integration with the OP, and we added this fallback feature, and we just don't even care. Like to us, it's just like it's not that important to us whether there's fallback, whether people post to multiple DA layers. I think there's people who think that, for example, you'll post to multiple DA layers, and like maybe there'll be some multiplexing API or something that all the rollups start using and whatever. But the truth is, like, once everything goes to ZK, everyone's just gonna be posting proofs lots of places, and like none of this really matters, in my opinion. And so you want to just build for that end game. You want to just build for an end game where there is already this kind of like world where people are like trying to verify things or post post data like in a bunch of places and post proofs in a bunch of places. And I just don't think this is really like really where the industry should be focusing on, is not making DA more resilient or something. It should be like scaling up the bandwidth for people to build the next like actually emergent, interesting applications of this technology. And it just feels like a distraction or like unimportant thing. Now there are ways in which I think it is important, and as I mentioned, like the fallback thing or reliability, or especially in ZK where you don't have to look at all the like transaction data before that proof, like sure, like it starts to make sense. But I just think it's not really where like the frontier is getting like the interesting parts. I think of this, especially in DA, is like where is the frontier actually moving to like allow people to do the things that you couldn't do on blockchains before. And that's at Celestia, that's the way we think about it. We're like thinking at the tip of it rather than the kind of like how do we make the some number of chains more resilient or something like that. Like that's, they want to do that, they can already do that. Like it's not, it doesn't really matter to us.
Got it. You would think that the DA itself is decentralized enough to have that resiliency built in anyway. Said they would.
Of course, I mean, that's why we are building that network. Like each one of us probably believes that their network is resilient enough to be able to handle faults, able to handle network partitions, liveness issues, and so on.
Got it. Let's look at the other side, which is actually the ecosystem growing and multiple chains. So we talk a little bit about interoperability, and you have different technologies that more and more there is attempts to have interoperability layers, whether that's through bridging or common provers and whatnot. What role does DA play actually to facilitate this interoperability, to make it abstracted completely for the user, that no matter where your funds are coming from or going to, you will be able to transact? Maybe Muriel, will take this first.
Yes, I think going back to this idea of what do we do on our computer, right? And what do we do on a machine? And they are do we bridge on a machine, right? If I again I have two applications going on what and I need them to have access.
I copy paste usually.
I like it. Yeah, you copy paste, right? And what do you do when you copy paste? You copy to something. And then, something else is able to grab from there. But you don't say, hey, I've got my bridge between, I don't know, whatever applications you're copy pasting from, right? You basically, you put it in memory and you both have access to the same memory. So that is a really powerful abstraction, right? There's a reason we do that. Again, let's think about, we're running this as a computer, as our own machine. So having the data access, which is clean, which is like, well, look, I put it, it's this variable. And of course, not having to tell you, by the way, it's this variable, in this cell of your memory, because, the other computer doesn't want to know about the cell of the memory, but just, just like, hey, here it is. It's available. It's accessible also, right? I think that to me is much more scalable, because otherwise, I mean, as the number of applications grows, right, the number of cross chains is going to grow in a way which absolutely is not linear and does not scale, right? So, every time you have a new application, you need to then create one to everything. You're going to have like a complete graph of applications with like all the cross chain among them. So it just in terms of, if you will, computational hygiene, and again, things that we have been doing in computer science for a long time, I think that really looking at just accessing the data in a common way is a powerful and scalable abstraction.
I slightly disagree. I would say that. I would say that. See, if we actually take a look into the computer architecture, these are about caches that you are talking, and one of the main problems with scaling up processors has been that cache size increasing our problems, right? So if we are reliant on caches, then they are the bottleneck. Now coming to actually why this model doesn't fit with my mental model, and I can be wrong here, is that an application should not be able to access directly another application, because the problems had arisen in 80s and 90s when there was no kernel level abstractions, cutting off accesses, and when one application could access another one. And I know you're not talking about that. No,
you have an excellent point there, right? So you're correct. I mean, when I was doing this back in the 80s and 90s, I would have to check that, my memory was bleeding all over the place, right? And I'd be like, what is this result? And have to go and, probe and sample and, but it's exactly as you said, right? We have the kernel level abstractions, which prevent these kinds of messes. That's the availability, that's the atomicity, that's the consistency. So if we have in Web3 the atomicity and consistency, then we don't have to worry about it. But you're absolutely right. That is crucial. And that is part of the abstraction.
Yeah, absolutely. And there I fully agree. And that's why, we are building Avail Nexus, small shilling, because that's what it's about, right? But yeah, I mean, see, this is the mental model from where we started. And then we thought like, okay, if we can actually have these ZK proofs of execution, and then a shared source of truth, which is probably what she is also attributing to, right? That the same machine where you have all these applications residing, if that is the mental model, then it becomes very easy to do trust minimized message passing. That's what it's about. Like, we want to be able to do message passing in a trust minimized manner. Message passing in a trusted sense has been done forever. If you trust the kernel, if you trust the OS, if you trust someone else to be doing that job, then that could scale. Like, if I trust that the other counter chain has done its job, then I should be able to trust that bridge completely. But we have time and again seen that if you trust any entity too much in crypto, that's a point to get doomed, right? So that's why we are trying to provide trust minimized interactions between these applications, and that's why we are building Nexus.
Yeah, I have a question about maybe Optimum actually, in the sense that the way what you're describing is almost like, sort of like when DA was first interesting. That's like, it was like a way of thinking about security of blockchains from scratch, right? Like and I feel like but it was like after we had seen what, basically people had tried a bunch of stuff to scale L1s with novel consensus or whatever, execution stuff, whatever. But to me, what is striking through of what you're saying is actually that this is that what you're trying to do is basically like, okay, we see even how people want to build rollouts. We even see if people want to like basically connect and interoperate different components of different blockchains that don't inherently trust each other. And what you're saying is like, what if you could have connectivity between all these different blockchain resources, but again, similar to DAS or like the lazy ledger paper or whatever. You're saying, well, maybe, here's like a first principles way to think about how these systems would do that, like understanding the limitations of even like what, for example, like Avail or Celestia are thinking about in terms of like generalized interop. We have like ZK accounts, they have Nexus. It's like, but that's like us being like, okay, that's the second problem after you make this really high throughput DA. And you're thinking of as like, well, actually, here's a thing that here's an approach that actually takes that into account and is like, but here's like what actually becomes the problem when you play it out or something. So were you saying, yeah.
You guys said it too many times. I lost count.
Well, no, I'm just trying to contextualize what you're doing better, because I think yeah.
It is. It's a completely principled. Like you're going to read and write,
Mhm.
right? And you're going to read and write, except it's in a permissionless system.
Exactly.
In the end, so if you think, for instance, of Web 2, right? It's Web 2 is just Web X, but we have an abstraction which is a socket, which is like, it looks to me like a protocol system, and I don't think that the nodes in between are reliable or whatever, right? But I figure it out end to end to manage. The same way, like the sockets there, like there's a socket. It looks to me like there's a battery. I know that there isn't a battery, but as far as I know, there's a battery, right? And the whole abstraction of how those electrons got to me, whether it's from a solar panel or something else, I don't care. Right? And so that's it. I think that the abstractions, but so I love the way you said it. Thank you for saying it.
I got a wink from the back about the time of this panel. First of all, actually, the best panel is the ones that you don't have to moderate. So thank you guys for agreeing and disagreeing. That's pretty good. Perhaps like a short window about what you are looking forward to, essentially the innovation in the DA space specifically, what maybe your project is working on as the next frontier. Would love to hear that. Maybe Kimura-san, you can start.
I think the layer will also work for interoperability among layer 2s, I think. And for example, I think IBC is one of the best interoperability protocol among ecosystems, and to realize IBC among layer 2 blockchains, we need a state proof for layer 2s. So in that case, the layer will work to submit the state proof for layers between layer 2 blockchain and layer 2 blockchain on top of that layer. So the innovations of interoperability in the spaces will be the next important topic for us, I think.
So I think that working on abstractions, abstractions are not abstract. They're there to be realized and give us something that's powerful and that has serenity. The same way that sockets, all the sockets I talked about have serenity. I think that is very interesting.
Yeah, I mean, for us, the opposite, tangible, like tangible applications. I think Avail is probably the same way. It's like we're thinking of like, okay, well, we just dropped, we just brought all this massive, DA throughput to the industry. And now it's like, well, what do we do with it? We can basically copy paste the things we've already been doing, like OP stack chains and have SVM, move, whatever L2s. And those things are actually pretty exciting because they do open up some new distribution for those stacks. But what we're really excited about, like really, really excited about, is I think two categories. One is basically people building actual applications that are uniquely unlocked by lots and lots of throughput. And we think of that, we call those like we want to bring back the original Ethereum homepage like rallying cry, which was around building unstoppable applications. So like we think of like what are the things that actually at really high throughput need to be built on the infrastructure like this. And the second one is what are the really weird things that should be on chain that aren't before. So there's a project called Chopin, for example. They're build basically allow you to basically just plug in a roll up in DA into with DA into a Next.js pipeline. So you can just basically take any application that you're deploying in Next.js and you're just like, okay, well now it's verifiable. And that's going to take a while to really play out. We need like way more DA throughput to make that work. But the point is like, that's where we're going. Like we're actually going to a place where there's going to be a significant increase in the frontier of things that can be put on chain. And I don't think people, a lot of this, their cynicism about infrastructure and about like the industry broadly doesn't really fully see this yet. And that's actually one of the most exciting things, is seeing that before and actually meeting the people building some of these early things. And then I also think I'm excited for the types of innovations that are happening on at the infrastructure level on top of this. When you go to this model, you can actually go and like scale execution way beyond anything you do in Monad or Solana or whatever. And like, so you have like people like Megaeth and others that are like, okay, like we're going to bring this like all the way down, performance wise on top of the stack. And then we're going to have, get all these people to build applications like that are like completely impossible before this. So I think that's that this next phase of crypto is actually, it's not just like nebulous consumer applications. It's not just like, some vague like things where we need people to build applications. Like it's actually like this, what's enabled by this, like the emergent properties are enabled by this, like by putting really actually this breakthrough really in underlyingly it's this the DA throughput breakthrough.
No, I completely agree with all the things that they all said. So, I mean, I will just wrap it up, but just say that, when you have the DA throughput, as you mentioned, it comes to the what you are doing on top. On top, what you are able to do because of this architecture that you have enabled is to have trust minimized interactions between the applications. That's one. Build new types of applications, which he said is another second one. And then three is have new incentive models on top, because you have now fragmented, and make sure that each information flow, a different information flow, can have different revenue model, and so on and so forth. You bring in newer players who can specialize only parts of the stack, which was earlier impossible because there was no incentive to do. There was no incentive for me to make a better EVM, because EVM is the status quo, and I had no other place. Like, I know I cannot generate an Ethereum's network effect if I have an EVM++. But right now you can, and that's why you can see like someone like a Monad doing excellent stuff there, and so on and so forth. So right, so overall, I think that is where the thing is going to go. I like the way that she put in terms of sockets. I call them blockchain primitives. Basically, once we have this shiny new architecture that we are building for ourselves, it's important for us to be able to take this and make sure that other people which are beyond this industry can use them without knowing all the jargons, without knowing what is a sequencer, what is a DA, what is something else. They should be able to use these primitives in the way that they want it to be done, and we should be able to still support them in the actual permissionless way that we came out to be.
Got it. Thank you. To summarize, I think I hear just one question, which is, what the hell is Crestal? So today, actually, what we're doing, we are providing some metrics and informational things about the different DAs, so you can go and explore what are the DA solutions. But it even supports even to deploying today an Avail node, the Celestia node this week as well, and many other DAs that will be deployable. So working in a way as well to simplify the wiring, and so builders can start building. I would like to thank you for your time and for a lively panel. We wish we had more audience, but thank you for being here.
Thank you very much.
And it's recorded, so watch it online. Thank you.
Thanks a lot.
Thank you.